Alright, here goes the review. To write a direct variation equation, you need the direct variation equation, y equals kx. So we're going to take the values for x and y and plug them in where they go. And then we're going to solve for k. So we're going to have 9 equals k times 4.5. So we'll divide both sides by 4.5 to solve for k. And when we do that, we get k equals 2. So that's what we're going to write in the function y equals kx. We're going to put the 2 in for the k. So that's part of the point, and now we just have to graph that. So this would start up 0, so right there, and our slope will be up 2 over 1. So from that red dot, we'll count up 2, which that box right there is 2, and over 1, so halfway between those two, and then we'll keep going up 2 and over 1. So the graph will look like that. On number 2, this one is a inverse variation function. So we need to use the equation y equals k over x. Now we'll plug in the numbers for y and x to solve for k. So the equation will be 12 equals k over 4, and then we need to solve for k. So to do that, we'll times both sides by 4, and we get k equals 48. So we write that in the equation y equals k over x, and we're going to put that 48 in for the k. Just like this. So that's the final answer to number 2. In order to figure out if a data set is direct variation, what we're going to do is divide the numbers. We have to divide y over x and see if we get the same number every time, if we get a constant. So we would test 960 divided by 3. We would test 720 divided by 4. And we would test 576 divided by 5. We don't end up getting the same number each time, so that's not direct variation. We could try inverse, and it will be inverse if when we multiply the numbers together. If you multiply x times y, and you get the same number every time. So we could multiply 3 times 960, 4 times 720, and 5 times 576, and that's not going to work either. So since we tried dividing and we tried multiplying, and neither of them gave us the exact same number every time, the answer to this is neither. For number 4, we need to use our direct variation equation, y equals kx, and instead of using y and x, we could use the variables they give us in this problem, which is distance and time. So the y will be the d, and the x will be the t. So we're going to take the constant they gave us, which is 335, and plug it in for k. We're going to take the distance they told us, which is 6,700 feet, and plug it in for the distance, and we just need to solve for t. So we'll have 6,700 equals 335 t. And then you just solve that for t by dividing both sides by 335. And the time equals 20 seconds. Alright, number 5. Let's multiply. How about we do this by multiplying everything across the top together, and then we'll multiply everything across the bottom together. So first I'll multiply the stuff I circled in blue. 8 times 9 is 72. X to the 4th times x to the 1st, when we add those x's up, is x to the 5th. Y to the 2nd times y to the 2nd, 2 plus 2 is 4, and then we have z to the 6th. On bottom, I'll do the same thing. 3 times 4 is 12. We don't have any x's. We have y to the 4th. See how I'm putting the letters right on top of each other so they match up? And then we just have the z to the 3rd, so I'll put that right underneath there. Now we can go through and cancel out. 72 divided by 12 is 6. so we'll put a 6 on top. You could put a 1 underneath it, you don't have to. The x to the 5th, nothing cancels out. Those x to the 5ths. The y's are going to cancel out completely because there's 4 on top and 4 on the bottom. And for the z's, 6 minus 3 is 3, so it's z to the 3rd. So that's the final answer. Alright, for the division problem, what we need to do is flip over the second fraction and turn it into a multiplication problem. So I'm going to recopy 3x to the 8th over 4x to the 7th y. I'm going to multiply it by 4y to the 4th over 9. So first I'm going to real quick just cancel out these 4's. Alright, so we got rid of those 4's. Now I'll do what I did on the previous problem and just multiply everything on top and then everything on the bottom. So I got rid of the 4 on top, so I just have 3. And then I have x to the 8th, y to the 4th. On the bottom, I got rid of that 4, so I have 9, x to the 7th, y. So let's reduce the 3 and the 9. You can divide both of them by 3, so 3 divided by 3 on top gives us 1. 9 divided by 3 on the bottom gives us 3. 8 minus 7, for those 7 x's on the bottom, is just 1x, so x to the 1st. And then we have 1y right here, so 4 minus 1 is y to the 3rd. So xy to the 3rd over 3 is the answer. Number 7. Let's start off by getting rid of the fraction. So 10's being divided by x. Let's multiply by x, and it will cancel out. So I'll multiply this x by x, and that 7 by x. So I'm left with x squared plus 7x equals, and I'm not sure if you guys saw this, but there's a little negative sign right there in front of the 10, so it equals negative 10. In order to factor it and solve for x, we need to get everything on the same side. So we're going to take that minus 10 and add it to the other side. So this is what we're going to factor. X squared plus 7x plus 10 equals 0. So what do we multiply together to get that? X times x. The factors of 10 that add up to 7 would be 2 and 5. So the last step is to solve for each of those by flipping the sign. So one answer is x equals negative 2, and the other answer is x equals negative 5. Number 8, I'm not sure if I'm going to need more room to do this. First of all, look at the bottom of those. They are the exact same thing. So first let's cross those out and solve what's left. I'm going to solve this by moving these 5x's over to the other side by subtracting them. So 7x take away 5x is 2x. Those cross out, so we have 2x equals 14. We'll divide both sides by 2, and we get x equals 7. Great. We just have to check to make sure that x is allowed to equal 7. Well, if we look at the bottom, the one and only value that x is not allowed to equal is positive 7. So we can't have both of these things happening because that doesn't make sense. So the answer here is no solution. Alright, to get the zeros of a rational function, we need to solve for the x's on the top. So let's factor that x squared minus 6x plus 5. So two sets of parentheses. What are the factors of 5 that add up to negative 6? Well, negative 5 and negative 1. So the two zeros will be at positive 5 and positive 1. So right on the graph, I'm going to put those, 1 and 5. Zeros. Now we just need the vertical asymptote. To figure that out, we look at when the bottom is undefined. Since we have x minus 2, it means the vertical asymptote is at positive 2. So through positive 2, I'll make my vertical asymptote, And then just type that guy into the graphing calculator. Make sure you put parentheses around the top, hit the divide button, and then put parentheses around the bottom. And when you do that, you'll see a graph that comes up and then goes kind of straight up by that vertical asymptote. And then it's going to start by coming straight up by the asymptote, and then it'll turn and go through that 0. Alright, the last one starts out the same as number 9. We need to factor the top. So we have to find the factors of 20 that subtract to give us 1. The factors of 20. I'm going to go with 4 and 5. If we do 5 minus 4, that'll give us positive 1. So I'm going to write that over the x minus 4. And if you notice, we have the same factor on top and bottom. On the last problem, that didn't happen. But in this problem, we have an x minus 4 on top and an x minus 4 on bottom. So those are going to cancel out. What that means is the only thing we have left to graph is x plus 5, which comes from right here. So we need to go to the graph and go up 5, and then count the slope, which will be 1 over 1, so up 1 over 1. So our graph will be a straight line like this. It's not going to be that crazy hyperbola shape, it's just going to be a straight line. And now, if we were to have a vertical asymptote, it would be at positive 4. So in this case, it's not going to be an asymptote, it's going to be a hole. So the hole will be at positive 4. You flip that sign. So I'm going to go to x equals 4. I'm going to go up to where it meets the graph. And this one falls off just a little bit, so I'll make that line a little longer. And where that blue dotted line and the black line meet is where the hole would be. So the hole is right there. That's it for the review. Good luck studying, and don't forget to make your 3x5 card to use on the test tomorrow, because you will not be allowed to use your note sheet.